All right, since we have kind of like in the background decided that I would introduce the first talk, it would be great if you could start sharing the screen so that I can properly introduce you and the team and the title of the presentation. That would be the impact of interannual variability on the onset of summer monsoon.
Yeah, test, can you hear me?
Yes.
Okay, I will share my screen and my group member will start the presentation.
All right, perfect. I can see the slide in presentation mode, so thank you for that. We are all excited to hear about the projected impact of interannual variability on the onset of summer monsoon and extreme events over Indonesia and North Australia region. The team name of that team that worked on this is Fortepiano, and seriously, I like all your team names. I thought it was so cool that you have like cool team names. The team was mentored by Gise Shou-Kasa Ageng, and the team members consist of Shishiang Yang, Selin Acuña Kama, Teshavini Mahindra Pavase. And I'm sorry if I butchered your name. I tried to listen to the names before and I probably forgot how to properly do it. But so the floor is yours. Please start with your presentation.
Hello, I'll be the first person to present here. Am I audible? Just to confirm.
Yes, I can hear you.
So myself, Tejaswini Machindra Pausen. Yang, can you present the next slide? Yeah. So I'll be presenting some background. So as you can see, there are two set of images here. One is a image taken from NASA, which is about El Nino of August 2015, and the other is a representation of positive Indian Ocean dipole. These are the two very basic concepts that are taken into consideration. These are the two phenomena that we have worked upon. So El Nino, in a very basic sense, is a climate pattern that describes unusual warming of surface waters in the eastern tropical Pacific Ocean. So trade winds are weakened and the warm water is pushed towards the east, and which is the west coast of the Americas. When you talk about Indian Ocean dipole, in a very basic sense, it is a difference in sea surface temperatures between the western pole of Arabian Sea, which is the western Indian Ocean, and an eastern pole of south of Indonesia. As you can also see in the diagram, there is a temperature difference in both of the east and the west side of the Indian Ocean. Now, through this very basic information of this phenomena, one can infer that it greatly affects Indonesian and Australian rainfalls, which is also reflected by the available literature on these phenomena on these two separate geographic regions. These phenomena can also cause a lot of economic losses, which can, one paper that puts it into perspective is a paper from 2018, which studies the economic losses from 1997 and 1998 El Nino event on Indonesia. And the losses found by the study were around 3.7 billion US dollars, which is a high cost for a country like Indonesia. Next slide, please. So our area of interest consists of Indonesia and Northern Australia, which are latitudes from 20 degrees south to 0 degree and longitudes 100 degrees east to 150 degrees east. So one of the key reasons as to why we have chosen to study both of these separate geographic regions together is because both of them have one commonality, which is they receive year-round rainfall. So this precipitation begins to rise from October to November each year, and then peaks from January to March of the following year. Thereby, considering them as one region is very advantageous for us. And so now that we have covered the basics of our the phenomena to be studied and the area of interest, I'll hand over the stage to Celine to continue with data acquisition.
Thanks, Teya. Hi, my name is Celine. For the next part, I will talk about the data sets we used. There were mainly three variables we wanted to obtain, which were ENSO, IUD, and OSM, which is onset of the summer monsoon, that we'll talk about that later. For ENSO, we use the monthly Niño 3.4 index, which is a product developed by the Climate Prediction Center of the National Weather Service. For IOD, we use the dipole mode index, developed by the Working Group on Surface Pressure of the Physical Science Laboratory. And the last one, OSM, here we use the data from the Global Precipitation Climatology Project, the GPCP. They have 1 degree daily data available, which is awesome for the analysis, but the main problem here was that it only covers from 1996, so it wouldn't help us that much for our analysis. Therefore, we ended up using the monthly dataset that, although it has a lower spatial resolution, that is 2.5 degrees each grid, the years of record are longer, from 1979 to the present. And just to mention it, all of them are divided by institutions related to the NOAA. Continue, please. Okay, so here we divided the data in 3 periods: long term, middle term, and short term. So it's a division of data for 40, 30, and 20 years. We did this to be able to see if there is a difference, if we use different periods, and how significant are those variations. Continue, please. Okay, as for our methodology, first, to obtain the amount of the OSM, we used the definition of Nichols from 1984, in which we needed to change the flow of months from the conventional year that goes from January to December to a precipitation year for the Southern Hemisphere from September to August of the following year. After that, now that we have a precipitation year, the amount of the OSM will be decided by the first month where the precipitation reaches 15% of the total precipitation in the whole year. So the image at the right side of the chat bubble is like a map that we'll obtain for one precipitation year. And for instance, here, the green boxes, which would be the grids, represents that for that area in that precipitation year, the OSM starts in October. And for the other colors would be another month and so on. And once we have that for all the precipitation years, we obtain the mean per period, short, middle, and long term. Then we also obtain the mean of the ENSO index, which is the ONI, per period too, and the same goes for the DMI. Lastly, statistical analysis is applied to see the teleconnections. And for this, Pearson correlation was used between each OSM mean with their respective ENSO or IOD indices, and this per period too. And in the next part, my teammate will explain about our results.
Hi everyone, I'm Zhixian Yang, and I will introduce some results and conclusions we obtained from the analysis we described above. So from the positive correlation between the Niño 3.4 index and the onset of summer monsoon over the Indonesia and North Australia region, we suggest that an El Niño event is highly relevant to the delay of OSM, and this trend didn't change too much from long term to short term. On the other hand, the Indian Ocean dipole behaves differently from the El Niño. We can tell a negative relationship between it with the OSM, and this relationship is significant in northwestern Australia. Furthermore, comparing with different periods, we found that this relationship becomes weaker in northwestern Australia, and a new negative correlation center spawns in northeastern Australia in the short term. Likewise, IOD have a positive relationship with OSM over Indonesia, but this relationship becomes weaker in short-term period. So we got some conclusions. The ENSO's teleconnection patterns is different in different periods, are positive and show a high consistency. And a persistent negative correlation between the IOD phase and OSM in Northern Australia exists. These results correspond to those found by the former researcher. And the IOD connections have undergone some changes in recent years, which might indicate a changing climate. So in our opinion, to improve the findings in this study, we suggest that it's better to use finer datasets since the resolution of the monthly GPCP data sets we use in this research is only 2.5 times 2.5 degrees, which is kind of sparse. And the methodology applied could be used with climate projection data sets for a variety of models. In other words, the CMIP6 data, to understand the relationship with these climates variability with OSM and observe which have a better performance. After further investigation of the effect of these variables corresponding to monsoon onset, these results can be applied to spatial temporal land use and land cover variations throughout the decade. This helps to understand the severity of local struggles. This is our presentation. Thank you for your listening.
Yeah, sorry, I was clapping in real because I couldn't find the emoji quick enough.
Same. I have some questions of my own, but I would open the floor to others for questions first. So if any of the other teams have questions, or honestly, if any of the team members still have questions they wonder about, I'm curious to hear those. Yeah, Birgit, please.
Yeah, I would have a question. So you chose, I'm not entirely sure that maybe I missed it, why you chose 2018 as the end point of your analysis. Is that just because that was where the data was available, or was that out of a specific reason?
Actually, the availability of data extend to 2023, even this year, but we chose from 1979 to 2018, just the entire period will be 40 years.
Yes, okay, I see.
Yeah.
So I was just wondering, so if you do correlations, if you tried to kind of shorten the period by 1 year or 2 years just to see if there's an endpoint problem, for example, kind of like if the last year is so exceptional in one way or another that it can influence your correlations. Did you think about this, or was that something that that didn't matter? It could be that it's stable enough, that the correlation is stable enough that it doesn't matter.
Actually, we didn't consider that factors when calculating the correlations.
Okay. Yeah, no, that's totally fine. I was just wondering. Thanks.
Are there other questions? One thing which I was struck by is you attributed the difference between the short and the medium and the long-term predictions to climate change. And of course, it's true that there's a different set of climate states from 2000 to now, roughly, than there was in the 1980s. But I wonder if you thought at all about the underlying data. So did you, for example, do some investigation to understand how GPCP is made? Like where those observations come from?
Well, according to my knowledge, they are derived from satellite observation and regrade into and make them into graded data.
Yeah, that's right. And they're just so it's clear, they're not made from measurements that are sort of directly sensitive. So they're an inference about precipitation based on how cold the clouds are. But I'm wondering if you think the data obtained in the 1980s would be exactly the same as the data obtained more recently.
Maybe we didn't count that into consideration when we're hypothesizing things, and maybe that's
you would make, I guess the idea here, you said at the end, would be to look at this in models and maybe to ask how ENSO and the IOD change in the future so that you could make some estimate of the monsoon onset in the future. Is this how you guys are thinking about it? If you
Actually,
Go ahead.
it involves another factor is the credibility of the projection of El Nino and IOD. If both this tropical interannual variability is predictable, then we can use the predicted index to predict the onset of summer monsoon over the INA region. Likewise, like we do on the reanalysis data.
Yeah, so and maybe let me say, just because you were the last one, you don't have to be the only one that answers these questions, Zishan. Maybe some of your other teammates want to pipe up, but I'm curious how you imagine someone who's trying to plan using this information. So you show that there's this relationship that occurred in the past. And if you're trying to imagine a climate impacts and someone trying to plan for climate impacts, what would be the step? How could people use this information? Maybe
Actually, that's also the thing. That's also the thing we're considering during the past few months, and well, and I frankly I didn't have. I still have the same questions, and we're reviewing some literature and see how the former researchers do the similar things, but yet this are stated, but we don't know the answer yet.
Yeah, it's hard. Someone like me who's like a physical scientist, I don't know how people use this information, how to make it useful. That's a good question. Birgit, you had another question real quick before we move on?
Actually, I just wanted to say I really like the idea that you had, that you would want to use what you did here with the observations with the CMIP models, because that as a model evaluation person, I think this is a good idea, because you can actually kind of nicely see things that evolve in a model that you would see already in your observation. So I really like that idea that you had on that last slide thing. That's the only thing I wanted to add here.
And finally, Sintayehu has a question in the chat. Do you mind to unmute yourself and ask the question?
I saw it.
Yeah, well, maybe
actually
he or she can ask it out loud if it's okay.
Actually, the base is not so precise. The criteria we use is not so precise. It is just because the availability of GPCB monthly data is only 40 years, and we just try to divide it into 3 terms, and the threshold we chose is not as precise as precise as those people proposed in the former studies. What we found is try first, and then to validate adaptability, is if it is adaptable or not. So yeah, it's kind of casual.
Okay, let's move to the next. Oh, sorry, did somebody just ask something?
Thank you.